Welcome to example number 1. Let's suppose you throw a ball at a brick wall. The ball has a mass of 0.4 kilograms and it's moving horizontally to the left at a velocity of 30 meters per second. It rebounds horizontally to the right at 20 meters per second. So we're asked to find the impulse of the force exerted on the ball by the wall, and we would like to know what would be the average force on the ball during that time of impact. So, in solving problems like this, what really helps, especially with momentum problems, just like we did with energy problems, is you should draw a picture showing the initial picture of what's happening and then finally after the collision. So over here we have given the mass of the ball is 0.4 kilograms. The velocity is written here as 30 meters per second. This is the initial velocity. But you do have to be careful with this. This is the velocity. Remember, velocity is a vector. And this is going to the left. So often people will forget that we need to include the sign with our velocities. So really it's going negative 30 meters per second, and then the final velocity is really positive 20 meters per second because it's going to the right. So in part A, we're asked to find the impulse, which is represented with this capital J. Now the impulse can be calculated if we knew the force and multiplied it by the time of impact. But we don't know how much force there is. We do also know that the impulse is equal to the change in momentum. That's really the final momentum minus the initial momentum. So the impulse can be calculated by taking the mass times the final velocity and subtracting mass times initial velocity. So let's go ahead and substitute in here. We have a mass of 0.4 kilograms. In fact, we could rewrite this if you'd like as mass is common, so it's mass times velocity final minus velocity initial. So 0.4 kilograms, and then the final velocity is 20 meters per second, then minus negative 30 meters per second. And so then really we have a change of velocity of 50 meters per second. So the common mistake that people typically make in this problem, had you tried this on your own first, you probably may have made the mistake of just going 30 minus 20. But that wouldn't be the change of velocity. That would be just really slowing it down from 30 down to 20 in the same direction. Really think of it as the ball comes in, it hits the wall, has to stop and lose 30 meters per second, and then throw it back in the opposite direction, 20. So the total change of velocity is 50 meters per second. So when you multiply these two out, you should get 20 kilograms times meter per second. Or you could also write it as 20 Newton seconds. And this is to the right. That's actually in the same direction that the force is acting. Remember, we got an answer that was positive, so that means that's why it's to the right. In part B, we're now asked to find the force of impact. We're given the time of impact right here, delta t, and we need to know how long, or how much, the force was that acted on the ball from the wall. So we also know that the impulse can be calculated by the force multiplied by the time of interval. Now we just calculated in the previous part that the impulse was 20 kilograms times meter per second. And we're looking for the force. The time of impact is 0.010 seconds. So if we did 20 divided by 0.01, we get a force of 2,000 newtons in the same direction of the impulse. So this is to the right. And that makes sense because the wall would be exerting a force on the ball as it's in contact with that to the right to change that ball and make it accelerate to the right. And that's it for this example.